Okay, so I'm going to start going through the AS Chemistry Enthalpy Changes Assessment Point, question 3 from January 2010. So question 3, glucose C6H12O6 can be completely combusted to give carbon dioxide and water. What I want chemists to be doing is making sure that they take note of the molar quantities and just what you've got in each compound. Now, it asks you, in the body, the conversion of glucose to carbon dioxide and water takes place in a number of stages catalyzed by enzymes. What is the name given to the oxidation process in the body? The answer is respiration. This person here has got 1 mark. Why do you know that? Well, respiration is an example of an exothermic process that we have actually gone through. So well done for getting 1 mark. Next, there's some information given here. So if we look at the information given, there's a mass of glucose given. There's also a mass of water. And there's a temperature change. There's specific heat capacity given, and the density of water is also given. Now, because you've got a temperature change and the specific heat capacity, then this is the correct equation to use, Q equals mc delta T. To get 2 marks, you need to use this equation correctly. Here the candidate has got 100, which is the correct mass. And the candidate has used C and delta T. And here, the candidate has got the answer in joules. The candidate has got 2 marks because the candidate has been able to give the answer to kilojoules. Now, some places where a lot of people went wrong is they used this value for their M, which might have got them 1 mark for just error carried forward, which is ECF. So that's the first mistake I've seen. The second mistake is just putting their answer in joules. I've also seen, rarely, but I've also seen the delta T not calculated correctly. So just be careful. But as you can see, this candidate gained 2 marks. Next, it's asked to calculate the amount in moles of glucose that is burned. So it's always wise to just pop the equation there, even if you think that you know it that much that you don't have to write it down. So this candidate is written it down. Mass over MR. So the mass of glucose is up here. Just getting a different colour. I'm going to put this in green now. So the mass of glucose is here. Mass of glucose. There we go. And the MR has been correctly calculated. And if you're thinking, where does that come from? Well, the glucose is back in the question. And this candidate has calculated correctly. Next. Part 3 is for 2 marks. Calculate the enthalpy change of combustion of glucose. Now, enthalpy change of combustion. I want everybody to be thinking enthalpy change of combustion is an example of an exothermic reaction, so you're going to have a negative sign. This candidate got the negative sign, therefore gaining 1 mark. Well done. You couldn't have gained 2 marks if you didn't put that it was negative. So be always making sure that if a reaction is exo, it's negative, and if it's endo, it's positive. Okay, really important. Some people miss this. It says give your answer to 3 significant figures. As you can see, this candidate gave the answer to 3 significant figures, even though the calculated value is there. So well done. Now, I'm just going to pick a different colour. I think I'm going to put in orange. What I've seen were mistakes. Okay, so mistake, I've seen people multiplying instead of dividing. Now, the reason that we divide is because you want to get the answer in kilojoules per mole. Kilojoules per mole. So you want kilojoules divided by mole. So in other words, you want answer to part 1 divided by answer to part 2. Okay, so that's question 3. Okay, so the standard enthalpy change of combustion of glucose can be measured indirectly. When we say indirectly, you want to be thinking Hess's law. Think about what Hess's law, the definition of that is. We have been asked to calculate the standard enthalpy change of combustion of glucose using the standard enthalpy change of formation. So, we've got to calculate the standard enthalpy change of combustion using standard enthalpy of formation. Again, Hess's law. This is what we're doing. Now in green I have highlighted the equation again because I just want everybody to understand how important it is to look at the equation to realise what we have actually got. So I've put 1,666. So that means what? Now this candidate has drawn arrows from above down. That shouldn't actually look like that. I'm going to take it over to the other side and do what we should see in blue. I've actually marked this question wrong and I'll explain why. So go over here, follow the blue arrow. So if we've got A reacting to give B and we are using data that's enthalpy change of formation. So underneath here in blue we should have elements. So the amount of energy it takes to form glucose is represented by this arrow now, which will be -1250. Let's go from there. I'm going to just change my colour, just bear with me a second. So I'm going to go, right, I'll see this colour shows up, it's going to be a lilac. Now the amount of energy that it takes to form 6 moles of CO2 is going to be 6 times -394. Because I've got the date from there and I've got 6 up there. Right, I'm just going to grab a different colour, I'm going to do it in like a pinky red now. Because we've also made 6 moles of water, that's going to be 6 times -286. So that's where the date is coming from, and that's where the 6 is coming from. Now, we're going from Leeds to Bradford, A to B. We'll just do this in black. So we're going from A to B. So the blue arrow is actually against the flow, so it's -1250. The lilac and the red are going with the flow, so that's plus minus whatever that value is. I haven't got a calculator, you have, you can do that. Plus minus the value of the formation of 6 moles of water. Now if you type that into your calculator, you should get an answer, and it should also be minus. So remember, it is a combustion, it's going to be exothermic. 3 marks available here. This candidate hasn't got 3, they have got 2. 1 for putting the right right sign for exo, and they will have got a mark as well for having this correct. Now for 3D, it says to suggest 2 reasons why the standard enthalpy change of combustion determined experimentally are less exothermic than the calculated theoretical values. Now there's a number of ways that you could have answered this. Here this candidate got 1 mark. I mentioned it wasn't in a closed system, so it wasn't standard conditions. What you could have done, I'm just going to type it now, is put not fully combusted, or something on the lines of not everything burns. What else could have done? Just trying to pick a suitable colour. Sorry, this blue's not looking really good on this. You could have had not fully combusted, not everything burns. Something along the lines of not under standard conditions. And something along the line of heat released to surroundings or heat loss. Okay, so that was all out of 12. I just want you to be seeing now what you got out of 12 and how you could have made it 12. Mistakes that I did see, these are going to be shown in pink. So mistakes that I did see, some cycles did not have anything to do with moles, so they didn't include mole ratios, so some people did not times them by 6, so that means 6 moles of oxygen, 6 moles of carbon dioxide, 6 moles of water. And a lot of people didn't get 2 marks for 3D either. So